Hi, thank you for tuning into CMTEQ channel. In this video, I'm going to show you 4 simple ways or methods to generate a PWM signal using an Arduino Uno board. As you can see here, I've got an Arduino board with a rather interesting add-on here, and I'm currently generating a 490 Hz frequency with a duty cycle of 42%. Now, this is just a one way to generate a PWM signal that I've got loaded in here. If you stick around, you're going to learn 4 simple ways to generate a PWM signal with an Arduino Uno powered by the Atmega 328 microcontrollers. Now, before we can dive in, let's make sure that we are all on the same page. If you are here, it basically means you already know what is a PWM signal and its importance in power electronics, controllers, gate drivers, and obviously embedded systems application. But to make sure that we all understand the signal that we are currently viewing, let's just recap quickly on what exactly is a PWM signal. Now, PWM, Pulse Width Modulation. As you can see here, I've got 3 PWM signals here with 3 different pulses, okay? So the pulses are the duty cycle. Here I've got a 20% pulse, and here I've got a 50% and the 80% pulse. Now, this is one signal that might be changing pulse at a different time, right? Because you can control it. That's where the modulations come in. You're not going to have a PWM without a controlling component, because PWM is basically a technique used to encode a message into a pulsing signal, a signal that is changing on and off. Now, here, if we go from 80% duty cycle to, let's say, 100%, as you can see here, I'm changing the duty cycle of this signal here. Now, when I go to 100% duty cycle, obviously these no longer qualify as a PWM, because now here you are still able to read 490 Hz frequency, but in reality, the frequency now change is now non-existent because the signal is now constant. It's no longer pulsing, it's no longer changing, it's now a constant 100% signal. You have to have a changing signal in order for it to be qualified as a PWM signal, right? Now, as a demonstrations, this PWM signal right here, as you can see, it's got a period of 2 milliseconds. Now remember, frequency is 1 divided by the period. That's what's giving us that 490 Hz frequency, because we got a period of 2 milliseconds. Now, this is a duty cycle, as you can see now, of 45%. Now, as soon as we increase this duty cycle to 100%, you're going to see that the positive width is now going to be equal to the period. Now, if the positive width there become equal to the 2 millisecond period, then you no longer have a changing signal. The frequency component is going to disappear. You're just going to have a constant signal. Look at it. Now, as soon as we reach the 100% duty cycle, the oscilloscope is no longer able to measure the frequency because it's non-existent, because we now only have a constant signal. It's no longer a PWM signal. Now that everybody is on the same page, let's now go ahead and discuss our very first method to generate a PWM signal. Now, the first of our 4 methods is the simple analog write method. Now, this is the key function that we are making use here, analog write, to generate the PWM signal that I've got right here in this board. Now, let's go into this sketch here line by line, because that's what is loaded into my Arduino board here. Now, the first line, obviously I'm just using the LCD liquid crystal library, to basically make use of that LCD display. Now, line number 4, I've got my PWM chosen to pin 9. Now, this is an interesting add-on, as I've said earlier. Now, with this add-on, you can do quite a number of things here. You can do current measurements and voltage measurement. This board can basically turn into a multimeter because you can measure the voltage and the current as well. Now, if you are interested in this add-on, please let me know in the comment section and I can make an arrangement for you. Obviously, there will be a cost attached to it. Now, this is my pin 9, as you can see from the Arduino, pin 9. Now, make sure that the pin that you select have a hardware implementation of a PWM signal, like pin 9 here. As you can see on the Arduino board, every pin that's got a PWM signal implementation, you're going to see a small mark on it. So that's 11, 10, 9. You got 6, 5, and 3. All those pins, they got hardware implementation of a PWM. Now, if you use a pin that does not support PWM signal, obviously the analog right here is not going to work. If you want to make it work, you have to use different methods. That's going to involve a lot of coding. Now we go into line 5. So I'm initializing a variable for my duty cycle. And line 6 here, I've got the pin for my duty cycle control potentiometer that is on A2. So A2 is somewhere here on my analog pin. It is routed onto this add-on board here. Then we move on into the setup function. Obviously, we initialize the LCD display because we want to display things in there. Then we set our pin mode, which is this pin here. This pin here, this is 8 and this is 9. Now, right now, I'm on the picture here, it is connected on pin 11. But right now on the board itself, it's connected on pin 9. So we have to set that pin as an output. Now we move on to the loop here. Now on the loop, obviously, now we have to initialize the reading of the port. So we are reading the port. The value that we read from the port is going to be ranging from 0 to 1023. Now, because the analog write function is expecting here a value of integer of 8 bits. Okay, so that means we need to map these to 0 to 255 for it to work well. Now the next line, line 19, where we're calling the analog write function, this is where it is hard coded with a 490 Hz frequency. Okay, and then we're controlling the duty cycle with the duty variable here. Now from 20 to down here is basically just me displaying whatever you see on the screen here when we control and we are getting. Now, if you remove everything down here, it's still going to work. Really, obviously, it's going to work. The only line of code you need here is basically analog write. So that basically means your PWM pin must be set up and the duty cycle reading from your potentiometer is set up. So you can complete this code with basically just a few lines, okay? Otherwise, if you want to be a bit fancy like me here, you're going to have all these other codes here. Now this sketch is already loaded into my Arduino board. I'm going to just go ahead and load it one more time just to make sure that we've got the correct script running into our Arduino board. As you can see, uploading, and it's done uploading, and obviously the duty cycle is at 81%. Now just to demonstrate quickly here, as you can see, so the PWM is at 490 Hz frequency, as you can see on the oscilloscope. My duty cycle is sitting at about 20%, right? So that is 20% of what? Of 2 milliseconds, which is the period of this PWM signal. Now, as I control my duty cycle, you can see now sitting at about what? 52% duty cycle. You can see I've got a period of, like, the positive width is like 1.06 milliseconds changing. So it's basically half of the 2 milliseconds. So it gives me 50% duty cycle. So like I said earlier, if I go all the way to 100% duty cycle, you're going to see the period and the width becoming equal. And at that time, you no longer be going to be able to measure the frequency of the signal because it's no longer qualified as a PWM signal. It's now a constant signal. So that is it, guys, for this first method. Now stay tuned so that we can now look into the second and third and fourth methods of how to generate a PWM signal using the Arduino board. Bit banging method. Now this method is implemented by simply turning the bit off and delaying for a couple of milliseconds, and then later on turning the bit on again and delaying for a couple of milliseconds. Now the frequency of this PWM signal that will be produced by turning the pin on and off and on is determined by how long you delay. 200 millisecond delay on low, 200 millisecond delay on high. Now if you want to know the frequency of this signal right now here, you simply have to do by dividing the time period. Now remember, you got 200 off, 200 on, which basically give you a period of 400 milliseconds. Now if you take 1, you divide it by 400 milliseconds, it's going to give you 2.5. Now without delay, let's go ahead and load this into our Arduino board and observe the PWM signal from this sketch. Right, so the script is done uploading, and we can clearly see we've got a frequency of 2.5 Hertz is displaying on our LCD display there. Now, do we have the same frequency here on the oscilloscope? So all we have to do here is basically to change the time division, okay, so that we can be able to read this very slow frequency of what's that, 2.5 Hertz that we calculated, that we can also see on our LCD display there. There we go, it's now available. So we can see there is a frequency of 2.479 Hertz. Now the period is 400 milliseconds and the positive width is 200 milliseconds. So the negative width is exactly the same. So we can indeed try to display it here. So let's display the negative width on our screen. There we go. So negative width 200 milliseconds, positive width 200 milliseconds. So it gives us a period of 400 milliseconds. Now remember, this one you cannot change the duty cycle because it's a bit banging PWM signal. Or if you want to change the duty cycle here, you need to shorten the time in which you are turning the pin on and off. Let's go ahead and try to achieve that. Now 200 basically mean we are on a 50% duty cycle. So if we want to change this to like a 30% duty cycle, you know what you're going to do. So let's try to change this here to 30 millisecond, and this here we're going to change it to 70 millisecond. Now this is going to change the frequency of the PWM signal because now it's only 100 millisecond period, and 100 millisecond is basically 10 Hertz, so which means it's slightly faster. But now we're gonna have a positive width of 70 millisecond and a negative width of 30 millisecond. Now let's go ahead and load this into our Arduino board. Done uploading. As you can see here on our oscilloscope, we are getting a frequency of 9.6. That's about 10 Hertz that we calculated, okay? And you can see that the positive width is 71 and the negative width is 32 milliseconds. So that basically sums up what we did on our Arduino script here. And by the way, if you know of any other method where you can generate a PWM signal using an Arduino at Mega 328, let us know on the comment section. And if you find this tutorial useful so far, please give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Now, because this bit banging based PWM depend on how fast you are turning your pin on and off, right? So that basically must take account of any piece of code or script you are executing in between. So if we want to speed up this frequency here, we need to remove this line of code here that we are basically using to handle the LCD display, or you need to find a way in which you're not going to delay the CPU process while you are toggling your pins on and off. So I'm going to go ahead and remove or comment out this script where I'm handling the LCD display. I will comment it out, and let's go ahead and reduce this delay to 1 millisecond so that we can get it to about 50% duty cycle. So we're going to put an on delay also to 1 millisecond. Now remember, you can indeed change this delay function to the delay microsecond, because the delay only on Arduino here is a millisecond delay. You can change it to the delay microsecond. That's where you can increase the frequency too much faster. Now if we come here on to our oscilloscope here, we can see that the frequency have changed and it's now 500 hertz, because it's a 2 millisecond period, and 1 divided by 2 millisecond is going to give you that 500 hertz frequency, and the positive width and the negative width are both 1 millisecond, as we've done on our code there. So if you want to make this faster, you can change it to a delay microsecond, and you're going to get a much faster frequency with the bit banging PWM. I've just changed the delay to the delay microseconds, and with a 250 microsecond delay on each toggle, so it's give me a total of 500 microseconds. Let's go ahead and load it, and on our oscilloscope here we can see that we've got a change in the frequency of basically 2 kilohertz, because that's what we get with the 500 microsecond of a period, and that is 250 microsecond for both the positive width and the negative width. Right, the next method on our list is the timer 1 method. So you basically have to include the timer 1 library onto your Arduino IDE, and much like the first method, the analog write method, this one is very easy. So you select your pin, right, and then you set the pin mode as an output. Then you do the initialization. Okay, so you initialize the period. Remember, the period is what define your frequency. So here on my comment here, I've got 100 microseconds period, that basically 10 kilohertz. So which means at 50 microseconds you double the frequency, that's 20 kilohertz. And then ignore all these line of code here for the LCD, and this part here is obviously for the duty cycle, because now remember, this method you can control the duty cycle much easily compared to the bit banging method, where the duty cycle is controlled by basically the time off and on delay. Right now here on the timer 1.pwm, you pass your pin and the value of the port. Okay, now the port value here is basically going to be your duty cycle value. Now let's go ahead and load this, uploading, compiling and uploading. As you can see, the period is 50 microsecond as we initialize it in our code, and we also have the positive width is at 30 and the negative width is at 19. Right, does that make sense? Well, we've got a 60% duty cycle here. Right, so basically this is how the timer 1 method works. So if we change here to 100 microseconds and we reload this again into our Arduino board, we should see a reduction in the frequency here of 10 kilohertz. As you can see there, the frequency changed to 10 kilohertz, and the duty cycle is standing at 58% there on the LCD screen. And here we've got the duty cycle, the positive duty cycle, positive width at about 59 and 60 microseconds. So it does make sense. So the timer 1 method seems to be a very solid method for all your project that you want to partake in using the Arduino board. Fast PWM method. Now in this fast PWM method, you basically will be making use of your Arduino Atmega 328 registers. Okay, so now if you don't want to use the analog write method, right, and you don't want to use the bit banging method, you don't want to use the timer 1 method and you want precise control of your PWM, well then you need to get familiar with the Arduino Atmega 328 datasheet. That is where you're going to start working with the registers. Now, two registers are particularly important to you. That will be your TCCR2A register and the TCCR2B register. That's the one you choose the prescaler for your frequency. Now, this means you need to know what is the clock frequency of your microcontroller. Now, these Atmega 328 that I use mostly on the Arduino Uno usually have a 16 megahertz frequency, but now you need to confirm that, okay? And once you know what it is, you can then come to this page 131 of the data sheet of the Atmega 328, and you're gonna find this table. Right now, this table is very important to you because now you need to set the bits for your prescaler. Now, when you set 111 on all these 3 bits here, CS22, CS21, CS20, that basically you are choosing the biggest prescaler, 1024. If you want to go to the 8 prescaler, that basically you must have 0, 1, 0. Okay, now once you load that in there, then the next thing you have to do is obviously to set the value for your duty cycle, and that will go into the register OCR2A. Okay, and that's work with the TCCR2A register. Now, once all that is ready, you can then go ahead and load. Now, forget this script here, that is just for the LCD display. So now I'm going to load this right now, and we should be able to see a frequency display on our oscilloscope here, because we do not have a frequency right now. So I'm going to go ahead and load it. Okay, it's done uploading. Now, what is going on here? Now, it seems like okay, 56% duty cycle here, 56% duty cycle, but I am not getting a frequency. I need to change to pin 11 there. So let's go to pin 11. Right, as soon as I move to pin 11, I'm getting my frequency here. As you can see, it's a 61 hertz frequency. Okay, that's mean because I'm choosing the biggest prescaler here, because it's now giving me a 61 hertz frequency. Now, if I want a bigger frequency, I must change my prescaler value. That basically means you need to work with this table. I want to change the prescaler here so that I can increase my frequency from the 60 hertz frequency that I have here. I want to change it to a smaller prescaler here. Okay, that will be, let's say I want to go to 8 there. That's 0, 1, 0. That basically means I'm dividing my clock frequency by 8 only. Okay, so now I'm gonna change it by setting this bit to 0. Okay, and this next bit also we're going to move it to 0. Okay, then we're only going to have CS21 to be at 1, just as the table. Now let's go ahead and load this onto our Arduino board, and we should see a change in the frequency here. There we go, we've got a bigger frequency coming up here. So now in order for us to read it, we need to change the time division here. Let's change the time division so that we can be able to read this frequency. There we go. Okay, so that basically means 7.8 kilohertz of frequency. Now we can still change the duty cycle here. With our potentiometer, we can change the duty cycle, as you can see. So this is it, guys, for this tutorial, and we've covered the 4 most basic simple methods to generate a PWM signal using your Arduino board. So that is the analog write method, the bit banging, the timer 1 method using the library, and the fast PWM mode where you can basically control your PWM with the registers yourself and get the value that you want. So thank you so much for watching. If you find this tutorial useful, please give it a thumbs up and subscribe to CMTEQ channel. Make sure you turn the notification for more tutorial of this nature. Until next time, cheers.